All right, we should be live. All right, so hello everyone.
Hello.
Welcome to
Ohayou
the
gozaimasu.
Intro to Godot workshop. This is the first workshop, introduction and everything. Yeah, so before we begin, does everyone have Godot 3.1 installed? If you do not, please do so pretty quickly.
It's
Otherwise,
super quick. It's really quick.
it is really quick. So if there's no questions, we will begin. It's a long one. That one. Okay. So, first introduction. I am Kat. I am the programming director. This says programming officer. These are from last year. I am passionate about free and open source software, which is why I like Godot so much, or a lot of the reason why I like it. I use and game primarily on Linux. This is streaming from Linux. After the workshop, if you have any questions about Linux, ask me. I really like to talk about it. Most of the software that I use for game dev is free and open source. Stuff like GIMP, Blender, LMMS, Vim, Godot, all of those things are all free open source software. I also compiled a list that you can access once we post the slides of all, like a bunch of free and open source tools that you can use for game dev if you're interested. So, next introduction.
Hey, I'm Duncan. I am also a programming officer. I used to use GameMaker Studio 2 as my main engine, but Kat convinced me to move over to Godot, and I think it's a lot better, but that's for a different day. I'm also a writer, and I like making story-based games with a lot of dialogue and interaction in them, and my games frequently feature demons and eldritch horrors of the underworld. That's not something you really need to know, but it's there.
One of the demons is on Discord.
He has a cell phone.
Okay, so what are we going to do in this workshop? We are going to go over why you should use Godot. If you are here, you're probably interested in Godot, so you probably already know a couple of the reasons, but we'll try to convince you even more. We're going to introduce the interface, take kind of a tour around, and just go through it. We're also going to be explaining some differences between Unity and Godot, so if you've ever used Unity, we'll kind of try to map some of that knowledge. We're going to be explaining the scene and object system, which is kind of a really powerful scene and node system, which is a very powerful aspect of Godot. It allows for a lot of really clever uses of scenes and everything. And at the end, we're going to be moving a sprite with scripts. So, what is a Godot? Godot is a game engine with many similarities to Unity, as I've said. This is Duncan's game base 6 in the Godot editor. Unlike Unity, though, Godot is free, open source, and community-driven and community-developed, which means the entire source code is up on GitHub. Its license model is MIT. So if you're familiar with the MIT license, it means that you can make derivatives as long as you kind of attribute that the program originated as Godot. Furthermore, you don't need to sign any license agreement to use or develop with Godot, so there's no things like revenue caps. They can't tell you what you can publish or can't publish with Godot, and so on and so forth. From their website, Godot is a completely free and open source, or Godot is completely free and open source under the very permissive MIT license, no strings attached, no royalties, nothing. Your game is yours down to the last line of engine code. Any questions on open source stuff? Like what license yet?
So, what is something that would break the rules of MIT license?
Well, we can pull up the license. I'm not super familiar with the actual text of the MIT. Ooh, where did that go?
Is that Linux?
This is Linux,
Yes.
as I mentioned.
You
I'm
really
gonna
are
have
into
to.
this whole open source thing, huh?
Yeah, a little bit. Workshop on slides. Sorry about that. MIT license text. This is going a little off topic, but I like it. So. Also, notice I'm not using Google either. I may have a tinfoil hat on.
Startpage.com? What?
Also open source.
Okay, so what browser are you using?
Firefox. So, let's read this. This is probably a little too off topic, but whatever. Permission is granted free of charge any person obtaining a copy of this software or an associated documentation to deal with the software without restriction, including without limitations of rights of use, copy, modify, merge, publish, distribute, sublicense, and or sell copies of the software, and to permit to whom the software is furnished to do so, subject to the following conditions. The above copyright notice and this permission shall be included in all copies. So that's really the only stipulation, is you can do anything you want, but you need to include this license in any derivatives. So yeah, that's basically you can sell the software. You can sell Godot if you want. You'd be stupid to do so, but you could. There's nothing stopping it. And that allows you to also sell your games without really like being being required to release your source code. That's what that's getting at. Does that answer your question?
Yeah.
Okay. So we can get back to this. Where did you go? Okay.
That's weird.
This just happens with
There we go.
presentations. You get them all set up, and then they fall apart. So, open source, why should I care? We were just talking about this. So, the easiest answer for game devs is fees and royalties. Like I mentioned once before, the other two popular engines are Unity and Unreal Engine, both of which require some sort of revenue cap or some sort of like deal with the company. So for something like Unreal Engine, the source code is actually available on GitHub. You have to kind of sign in and like sign a license agreement, but you can actually access and build Unreal Engine on your own. But the difference there is you have to still use a license agreement, sign a license agreement to use the software and to publish with it. So you're still under a revenue cap. You still have to pay Unreal Engine money if you decide to sell your game, so on and so forth. With something like Godot, which is free and open source, MIT licensed, those fees and royalties don't exist. Godot isn't a company, so you don't owe any company anything. They have no control over what you can do with your game or anything like that. Does that make sense? Yeah,
We
I just
basically talked about
yeah,
that.
just talked about that. So, enough about FOSS. I don't care. What else is Godot good for? So, the editor. The editor is portable, written in C++. It is relatively new, and it is very light. If you notice, the actual download size for Godot is like 30 megabytes. It's not very big, and that means the actual system requirements to run Godot on your computer are very low. The Godot as an editor can be run on a Raspberry Pi, so basically anything can run it. Also, a little tidbit, the editor of Godot is written as a Godot game, so it can be exported to any platform Godot games are exported to. That right now they're making a web editor because Godot can export to web as a platform. So yeah. Engine features, there's a simple scripting language. It's very similar in syntax to Python. There's also visual scripting, which we'll have a little note on later. C# support, C++, and C++ add-on support for the editor. Yes?
So how is the C# support? Because I've tried it out and it didn't really make much sense to me. But I do like C# as a language.
So there are some things you need to do differently, like one of the main things is how you deal with global nodes and singletons, but there are ways to get around that in C#.
Yeah, so there are a couple of differences. There's full documentation on it, which I would recommend reading. But yeah, because C# Godot wasn't intended to be used with C#, it was added later by like community. There's a couple of things that it doesn't mesh well with. But oh, that's bad. Oh, well, I didn't notice that. Come on. This is fun. No.
Do you guys need help?
No.
No, we got it.
We're just having issues.
Just talk it out, man.
Okay, so let's put this here. Not that, not that. Sorry. Just having some. I haven't streamed on this computer before, so we're having a couple of. That's not what I wanted to do. Come on. Interesting difficulties. Why are you not working? We may have to forego the stream.
Stream?
Yeah,
We're streaming?
We're
right now?
streaming.
Yeah, we're streaming to Twitch right now.
Come on.
Hi, Twitch.
Okay, so I'm just going to have it lock onto the engine. If you are watching the stream, the slides will be posted. I am very sorry. Okay.
Twitch chat, spam pod and chat.
Okay, so moving on. Sorry about that. So the engine features, going over that. Scripting language in, so there's also community bindings for scripting languages, so you're not really stuck with these 4 languages. So we have a slide later on that kind of details that later on, but there are community bindings for stuff like Python and Rust, so you can make games with those. There's also, it features a fully featured 3D engine with PBR support. Right now the backends are GLES 3 and 2, so that they can run on web and mobile. In 4.0, they're adding a Vulkan backend, and that's bringing a lot of very needed performance boosts along. That should be out like early next year. There's also a big difference between Unity and Godot is Godot uses pixel-based 2D or pixel unit 2D, so all of the units are in pixels instead of just like it being squashed 3D, which it is in Unity. So all of the 2D is separate. It's got separate rendering and everything. And so it makes a little bit more sense conceptually when you're working with it. So yeah, platforms. Godot can export to all desktop platforms, Mac, Windows, Linux, BSD. It can also do mobile and HTML5, which is
HTML5
web.
is not perfect.
It's
right
not
now.
perfect right now. It's getting better, hopefully. The console ports aren't supported natively because Godot isn't a company. They can't negotiate with the console providers to get like dev kits, and they can't publish dev kit code, so they can't support console export natively. But you can go through third-party companies to get your game on consoles if you so wish. There are also limitations, because it's open source, of course there are. Bless you. It is very good for personal, small team, and indie development. However, there is no solid asset store yet. Well, there is an asset store, but in order to publish on it, you have to release your assets for free MIT license. There are third-party asset stores that you can buy from, and you can also just import other stores' assets as well if you pay for them. But natively, they can't really include a asset store like there is in Unity. 3D performance at like AAA level isn't up to par with other engines right now, because they were using GLES 3, which is basically OpenGL for embedded systems. The performance wasn't great and the drivers weren't great for the backends. So in Godot 4.0, they're adding a Vulkan backend, which is a much more powerful, robust 3D graphics API, so the performance should improve beyond that. And it actually is improving because it's in development right now, and they're showing quite a bit of progress there. So there's also no commercial support. So this is why a lot of like AAA devs aren't, jumping on Godot like they are Unity, because Godot isn't a company and they can't provide any support. So if you were a company and you wanted to go with, say, Unity for your game, if you run into a problem with Unity, you can just say, hey, Unity, fix this, and they will, because you're paying them to. Godot can't do that because it's all volunteer community development, so any company that ran into an issue would be on their own to fix it. Documentation, it's actually basically fine now. When 3.0 came out, it wasn't great. There was a lot of undocumented functions and things, but now I don't run into problems with documentation at all. However, it's not nearly as popular as Unity, so you probably won't be able to find an answer on Google quite as quickly. But I would recommend just going through the documentation because it's great.
And then you can ask us.
Yeah. Always available in the programming channel. So, version we are going to be using is Godot 3.1.1. As long as you're running 3.1, you're probably going to be fine. But there are a lot of major UI changes between 3.0 and 3.1, so you might not be able to follow along if you're on 3.0. So, are there any questions before we get started on the workshop proper? All right, let's go. So, when you open Godot, you should be greeted with a scene just like this. You want to click on New Project after you make sure you're on 3.1. Let me do that now. So we can go New Project. Cool game idea that I'm going to abandon soon. So if it yells at you for not having a folder, you can create one with create folder. That's an awful folder name. And you should notice the choice of renderer. You all are probably going to want to use GLES 3.0. 2.0 is more for mobile and HTML oriented games. It will have better support on older platforms. But right now, 3.0 is fine. It's the default. Go with that. And let me fix the stream. So, it is fixed. Hopefully. So, it should open up a window just like this. This is in 3D right now. By default, it's in 3D. We're going to be working in 2D, so you want to go up to the top left and click on the 2D button. Should have a slide on that. Well, we also have a Godot to Unity terminology. So in the editor window in Unity, you have things like the hierarchy, the inspector, and the project view. So those map to the scene, inspector, and file system view in Godot. So we can see here that this is our inspector. So just to kind of demonstrate that, I just made a node. So this is basically an object, what an object would be in Unity. And on the inspector, we can see all of its properties. So if you're familiar with that, it's just right there on the right. Obviously you have your scene view. That's where all your objects are in the scene. And down here you have your file system, which is where all of your resources are, all of your scripts and everything in your file system. So, another big change between Unity and Godot is the project organization and what it actually makes for a project. So if you've ever used Unity before, you should be familiar with the giant folder that it creates whenever it creates a new project. It has several asset folders and cache folders and weird garbage. Godot doesn't have any of that. So there's a single project.godot file. That's where your whole project is described. You can edit that in like a text editor, and it's all just text. Assets that you import, which are just in the root directory, will have a corresponding .import file. That's all the import settings. Local import cache is stored in the .import directory that's hidden by default. You don't have to worry about that. That doesn't have to be synced in like Git repositories or anything. You can delete that and it'll re-import everything just fine. Inside of Godot, the resource folder, the root of the project, is referred to with res and then :// just like like HTML would be. So anywhere in your code that's going to refer to something in your resource directory is going to do so with that. And so you just like res : / path to whatever asset you're using. And that's really all that it creates in your file system. It gives you an icon by default, .png, and an environment. That's later for like 3D stuff. But yeah, that's really all it creates. So for actually organizing projects, this kind of just applies to all game engines. I would recommend having like an organizational system for putting scenes and prefabs and art, scripts, etc., all in their separate folders, so that you can find them easily and they're not all just scattered in the root directory. So this is the very different part to Unity. It is Godot's node system. So I've been referring to nodes a little bit. I created a node right here. So what is the difference between a node and an object? Well, in Unity, each game object is just basically an empty entity. It doesn't really have any behavior or any intrinsic properties. You have to add things to it called components, such as transforms, sprites, and those give it actual behavior and defines what it is. Godot, on the other hand, has nodes, and these nodes are defined very similar to object orientation, where you have an actual thing that you want to use, say a kinematic body, and that is a physical body in space that you move with scripts. So what that defines is all of the behavior that a kinematic body 2D needs is actually defined in that node. And it inherits properties from its parents. So kinematic body 2D right here, its parent is physics body 2D. So there is something that defines a physics body. It interacts with space, it has a position, it has friction or something, so on and so forth. So all of those are inherited by kinematic body 2D and then added upon. So kinematic body has more traits than a physics body does. And so as you go up the list, you have an is-a relationship. So a kinematic body 2D is a physics body, let's go back, which also is a collision object, which is a node 2D, a two-dimensional node, which is a canvas item, which is a node. And so all of these steps basically inherits and adds some amount of functionality and behavior to each of these nodes. So that was a lot of word dump. Is there any questions on that? Okay. So. Yep.
What about the things like control and spatial?
So those are sister nodes. So control and node 2D are sister nodes. So you can have just a regular node 2D, which I have right here, and it basically just is a position. So if we go back, hopefully we can go back. There we go. So you can see that control and node 2D both inherit from canvas item. So control adds separate functionality to canvas item than node 2D does. So in the context of the actual engine, control nodes are for UI. So there's like a canvas layer and you have controls like a button or something that is just on the screen. And then node 2Ds are for actual 2D space. All of your sprites and game objects in 2D are under node 2D. So we can see the same thing with animated sprite and collision object. They both inherit from node 2D, their position and everything, But animated sprite, adds sprite functionality, and collision object adds collision functionality. So they diverge there. Does that make sense? Cool. Does that make sense? Okay. Godot's scenes are also hierarchical in this way. So unlike, like Unity, nodes that share properties with their hierarchical parent will inherit those properties from them. So if we make another node 2D, under this node 2D, you can see that they're in the same place. That little plus sign, that's where the node 2D is. So if we move this bottom node 2D, we can see that they have separate positions, but as I move the parent node 2D, the bottom node 2D keeps its offset. So that's the kind of hierarchical relationship we're talking about. And that's very similar to Unity. But unlike Unity, a scene in Godot consists of just a single node. So in Unity, you can have, all of these things just spread out in the scene. They don't really have parents. They're all just, roots. So you can have like a camera and like a canvas item and a bunch of objects and enemies, and they're all, in the same layer. In Godot, you have to have a parent. So I can't have, or a master parent, basically. It's called a root. So I can't have anything that is a sister node with this top node 2D. I can call this root or scene or whatever I want. But anything I create needs to be a child of this. So I can create something else, collision object or whatever. So that means basically everything in your scene is going to have a parent except for this top root. So another note on that, in Godot 3.1, when you start a new scene with this plus arrow, it's going to tell you to create a root node. So this basically just defines what you want to use your scene for. So if you're creating a 2D scene, your root node probably wants to be 2D, so that everything under it is going to be, inheriting its position, so you can move it and apply, root node things. If you want a 3D scene, you probably want your root node to be 3D. If you're creating a user interface, you probably want it to be a control, or otherwise, it can be any of these nodes. Any questions so far?
Yeah.
So, let's say if I wanted to make a visual novel, would I take out a 2D?
Yeah, so that's 2D. So there's actually going to be a couple of different things going on there, and we'll get to this later. Both 2D and 3D games usually have a two-dimensional interface, and that's what it means by separating 2D scene and user interface. Is the user interface is basically a separate thing. It's going to be the frontmost layer all the time. Discord notifications. Hold on, let me kill that. Discord, where are you?
By the way, I love version.
Go away. I don't want you. Kill Discord. No. Go away. Okay. Should be dead now. All right. What was I saying?
User interfaces and why visual novels are 2D.
Right. So, in your 2D visual novel, you would probably have a game space where you have, your backgrounds in the back layer, characters interacting, and so on and so forth. So those would all probably be Node 2Ds, and then you would be able to, move them around, order them, and so on and so forth. User interface, you typically have a different relationship between all the things. They're usually the topmost layer, and you usually have, buttons and controls and text and everything all kind of like inside of each other. So that's, yeah. So you would probably have a 2D scene root and then a user interface node, which is called a control under it. And we'll get a little bit more into how you do that later. But yeah, we're just talking about nodes now. Cool.
Also, something else to note is you can mix 2D and 3D nodes in the same scene.
Yeah.
So like for a 3D game, what you would typically do is have a 3D spatial as your root, and then you can instance in a prefab that has 2D nodes in it or control nodes for your UI, and they'll just work together seamlessly.
Mm-hmm. Something to keep in mind for that though is if you have a 3D node and its child a 2D node, you have to keep in mind that it's not going to be inheriting almost anything from that 3D node because they don't have anything in common to inherit. So yeah. All right. So yeah, we will make a 2D scene with a sprite. So let's just make a 2D scene. We have our node 2D. This is typically called something like scene or root or whatever you want to call it. I'm just going to call it scene. And under it, I'm going to make a sprite. So typically you can just search for whatever you want in the nodes. I'm just going to search for sprite and just double click it to add it. And so now it has opened up in the inspector on the right. And so this is where we actually add the textures and everything to it. So for the texture, we just click on the drop down and click on load. So the only thing in our resource directory that we can actually load is this little icon.png, which is very useful to have. And we load it, and we can see right in the middle, we have a little Godot icon. Cool. Any questions getting that set up? All right. So I believe I just lay out those in text. You also want to save your project or your scene with Control S. And so it's going to save it as a .tscn, and it should be named whatever you named your root node. I'm going to create a scenes folder and just click save. You can hit Control S, or you can go up to here and hit scene, save scene. All right, so now that we have that done, that's just an image for the slides. And now we're going to be,
I think we've done this already.
yes, we have added the sprite, so more instructions. We've also done this. So now let's run the game. So if we hit this play button up here, it's going to run the default scene. However, we don't have a default scene, so it should pop up a little dialog box. So you just have to select your scene, and it'll play it. So let's see if I can capture this. Window capture. Cool game idea. We can, make sure that it's actually correct. And so, right. So yeah, this is what it looks like. You just should have a little Godot icon that is cut off in the corner. So, why does that happen? Let's switch scenes again. So, why does that happen? All right, so in the editor view, we have this kind of bluish box right here and here. I can show it here. So if we zoom out a little bit, we have this little box that's outlined in blue. So that's what is referred to as the viewport. And by default, the viewport's top left position is positioned at 0, 0. So that means anything between 0, 0 and your screen resolution will be shown. Anything outside of that will not be shown. So if we look at our sprite here, we can see its center is on 0, 0. So if we just move it, into the center of this little box and play, it will be centered. That's not it. Well, whatever. Sorry, stream, you're kind of getting a very bad view of this. But, yeah, that's what it should look like. So you can change the size of this viewport box if you go into project settings, display window. You don't have to do this now, but if in the future you want to change your viewport size, which you probably do, you do so in there. So another thing to keep in mind is if we go back and look at the position of our sprite, you can see that the Y is positive. This is contrary to Unity's Y positive being up. In Godot, Y positive is down. And the reasoning for this is your 0, 0 is basically the top left of the screen, or the top left of the viewport. And then as you increase your position away from the top left, you get closer and closer to the screen size, and that increases Y and X, but you're going from top left to bottom right. So that means that your Y is going to be down. Maybe a little hard to grasp, conceptually, but it's pretty easy to, get used to. It doesn't come up a lot as a point of confusion. Just remember that if you are making a script for something to go up, just remember you need to subtract a value rather than add a value. Does that make sense? Cool. Dragging. Okay.
I can talk about this part if you want.
All right. Yeah. Go ahead.
All
Do
right,
you want to sit?
so,
oh, you don't know how to work this, so you can just talk.
Okay. So now we're actually going to start programming stuff. So there's a few different ways to write scripts in Godot, and the most common one is to use GDScript, which is the main language that the engine uses. How many of you either know Python or are learning Python right now? Okay, most of you. So GDScript is really similar to Python. It's an interpreted language, it's not compiled, it's dynamically typed, so you don't have to specify types for your variables, although you can. We'll talk about that. And it's entirely white space based, so there's no brackets or anything like that. It's just about how you indent stuff. You also have the option of visual script, which is, if you don't know what visual scripting is, you basically have boxes floating in a void that you can drag around and connect to each other to create functions and create functionality. I hate it, and Kat does too.
Yeah,
so
it's a little bit more confusing than it is helpful, because it's so based on GDScript. You kind of have to think like you're programming in GDScript anyway, so it's easier to just use GDScript in my opinion.
Yeah. So there are also some other options, although these require a bit more setup. There's C#, which has been supported since 3.0, I think.
Mm-hmm.
So C#, it's what Unity uses. It's a compiled language. It's statically typed, so it's faster than GDScript. But there are some limitations, namely what you can export it to. Right now you can't export to mobile or HTML5, but in 3.2 there will be Android support.
And 3.2 is coming very soon.
Yes.
There's already an alpha out, and so they're just in the stages of bug fixing, and the release should be, in the coming months.
Yeah. Also, if you want to use C#, you have to actually download a separate version of Godot that supports Mono, and you have to install Mono on your computer. So it takes a little bit of setup, but if you're used to using C# in Unity and you want to keep using it, then it's a nice option. You can also use C or C++ using the bindings, and basically what that means is the community has written a way for these languages to interface with Godot's own source code, so you can use them to write scripts. And obviously, so C and C++ are also compiled languages, if you don't know. They're even faster than C#, and you can technically export to everything, but you need to do some workarounds for certain things. It's also a real pain to set up because you actually have to compile the bindings yourself, and it takes a bit of work to get it working.
If you're on Linux, it's not really anything special. You just have, a make file, and you export the shared objects and DLLs. On Windows, is a different story.
Yeah. On Windows, you can use Visual Studio, which I don't like to do, but if you're fine with that, you can use that. So that's an option, and we might be doing a workshop on that at some point if you're interested.
Mm-hmm.
There are also, as we mentioned earlier, some community bindings for other languages. There are literally too many to list, as in I literally couldn't fit all of them on the page. But you've got stuff like Python, D, Nim, Rust, Go. I think there's a JavaScript one. Some of these are better choices than others. Like, I wouldn't recommend something like JavaScript because it's going to be even slower than GDScript.
Yeah, Python and JavaScript, the runtimes are just basically too slow to really use in like a production game, but they're nice learning tools.
Yeah. And those all take some setup as well.
Rust, if you're familiar with programming Rust already, I'm not sure if any of you are, it is probably the easiest setup of all of the community bindings. You just set up, a regular script like you would in Cargo, and then it exports all of the things that you need to put into Godot. There's very little setup. I like the Rust bindings. Yep.
So we're going to be using GDScript for these workshops because it's the most common thing, but you can feel free to try any of the other stuff if you want to. And if there's an interest in doing a workshop on one of the other languages, just let us know.
Just, to get kind of a head count, raise your hand if you would like to see a workshop on external bindings like C and C++.
I like one on like C#.
Yeah.
All right,
Okay.
yeah. So we should do C#
All
and
right.
external languages. All right. So now we're going to be writing a script. You want to still do this?
Sure.
Okay.
So the way scripts in Godot work is you can assign one script to every object, and you just need to click the button next to the add script button.
Yeah.
Or you can go into the inspector and go to the script menu at the bottom.
May I ask a question?
Yeah.
Mhm.
What's native script?
Native script is what you use to use C and C++ and the other bindings.
Oh.
That's basically how they interact with Godot. Native script is, when you make a native script file, you're not actually writing in the language, you're just telling it how to find the compiled files that you have.
So yeah, we're going to be using GDScript. I would recommend changing the path because it's by default. I don't really like this. I think they should change this. By default, the script that you assign will be saved in the same directory as your scene file. That makes for some pretty disorganized project files, so I would highly recommend saving it in a different file. I'm just going to create a new folder for scripts, and I'm just going to name it sprite.gd. Once you hit create, it should open a text editor, and if we didn't say before, Godot has a text editor. It's pretty alright.
Yeah, it's
How does one get added in text editor?
So right on the top, remember how we went to 2D?
Yeah.
So there's a tab for 2D, 3D, and scripts, and also the asset library if you want to go there. So yeah, just at the very top, you can just switch between them.
Any other questions? Okay.
You want to go ahead? Should I do this?
Are we going to the next slide?
Okay, do that. There we go.
Okay, so like I said, GDScript is by default dynamically typed, so you don't need to assign a type to a variable. However, since 3.1, there is the option for static typing, which, if you don't know what that is, it's where you give each variable an explicit type when you declare it, and it will maintain that type for as long as it's in scope. And this helps, and unlike Python, where in Python you can specify types in functions, but it doesn't actually do anything, this does actually enforce those types, so it'll help you catch type errors in functions, and it makes the auto-completion a bit better since it knows the types of the things you're calling functions on. And in the future, like 3.2, it's actually gonna help with performance because it can do some things at compile time rather than at runtime.
Mm-hmm.
So the syntax, similar to Python, but it's kind of like JavaScript in that you declare variables with the var keyword. So that right there is how you would make a vector2. And if you're using static typing, you type var, the name of your variable, then a colon, and then the type, and then equals whatever. And you can also put the name and then just colon equals, and it will infer the type for you. It usually doesn't do that by default, so if you want to use static typing and infer the type, be sure to do that.
Mm-hmm.
And then you declare functions with the func keyword, like process, and just like Python, comments use a single hash character, and it's an object-oriented language.
Yep.
So we talked about the script editor, and just like Unity, Godot has two main functions, which are ready, which is like start, in that it runs once when the node is created, and there's process, which is like update, and that runs every single frame. And
we're going to have the slides, we're going to post the slides in Discord, so you don't have to take pictures if you don't want to.
And in Unity, to use delta time, which is something we'll talk about later, you would use time.delta time, but in Godot, the process function actually takes delta as an argument, and that is what you get that value from. So we're going to uncomment our process function by hitting Control K.
Probably not uncomment the actual comment. Should we go to the next slide?
Yeah. Any questions? So we're just going to make a simple script to move our sprite 1 unit per frame to the right. So to do that, we're going to make a variable, and we're going to use the translate function, which just moves the sprite by, or moves the node by a certain amount. So we're using type inference on this variable.
As you type, it should give you syntax errors. So if you forget to close something, it'll yell at you.
Not always in the best place.
Yeah,
but
sometimes it's not perfect. If you use an external editor, that depends on, your. There's usually a add-on for GDScript language support. I believe Visual Studio Code has a
Yes.
GDScript language server. So yeah. Should I go back to slide?
and then
Yeah.
translate in process.
So in process, we're going to just translate based on our speed. Speed is a vector2.
I don't think this is in the slides anywhere, but if you want, instead of var, you can say const, and it'll create a constant, which is just a variable that doesn't change. So if you want to do that.
So now we can go back here And if we hit play, our little thing will shoot off in the right at 1 pixel per frame. And yeah, so as long as it exists, it should be moving to the right. I'm going to interject for a moment, and I didn't actually know this when I made these slides, but in Unity, you may be familiar with the actual game being run, in a tab, and then being able to go back to the actual editor and see all of the gameplay, from the editor's point of view in real time. Unfortunately, Godot does not have that feature. They're working on it, actually. I don't know if that's coming in 3.2 or not, but they are working on it. But there is a way to actually access your objects while the game is running. So if you have your thing open, you can just drag it, and then a little thing called remote appears right here. And so you can access all of your scene in this remote, and all of these inspector things are now updating in real time based on your what is happening in your game. So I can set the node 2D's or the sprite's position to 0, and it'll reset. And this is very useful for debugging. Yes?
So where's the remote thing again?
It
So-
should be next to.
Yeah, when your game is running, the game has to be running. If you go back into the editor, it should be just above your scene hierarchy. Do you see it?
It's currently not working. I think it's a C# project for some reason, because I clicked this.
Are you on the mono version?
Yeah.
Oh, do you have the non-mono version on your computer?
Yeah.
Do you have Mono installed?
Yeah.
I think you have to tell it where mono is.
How do I do that?
You might just want to download the
Yeah.
solid version real quick.
Okay.
So just download that, and then you can reopen the project in the normal version, and it'll still work.
So another thing about this remote is that you can access the members of a script. So we created our little speed variable, and we can change that while the game is running. So we can make it -10, and we'll go in the other direction, make it 0, put this to 50. And so yeah, you can edit all of your objects and nodes and everything in real time. So there is, I can talk about this.
Okay.
Yeah. On the bottom of the screen, when you run your game, there should be a output tab, and there's a bunch of other tabs like Debugger and so on. So this output is basically a view of the standard output of your game, and it's going to basically tell you anything that is printed to the standard output while your game is running. So we can do something like in Ready, we can print game is running, and it is just called print. There's no fancy name for it. And then while you run it, it should have game is running in the bottom. So the debugger is a lot more complex than that. If you go into the debugger menu, you have all of these different things, and you can basically debug like every part of your program. You can make breakpoints by hitting the breakpoint thing next to the line number, and then the code will break there, and you can do all this debug stuff. That's all for a different workshop, but yeah, that debugger is there, and it's very useful for debugging. So yeah, that's it for this workshop. We're going to be, diving deeper in the next workshop, doing physics, doing, all the other stuff that is interesting about Godot. I would highly recommend just, playing around with Godot and trying to, make something in your spare time. That's, the quickest way to learn. I believe we have a slide here bookmark the documentation link when we post these slides. It is the most useful resource Godot has. You can also open the documentation from the editor window. There's the little online docs button, and also you also have a local version of the documentation. So this is actually a really cool feature. So if I want to search for vector 2, it has a little class thing that I can open, and it'll give me all of the documentation on the vector 2. So we can see all these methods that you can run on vector 2. Something else that you can do to get to that quicker is you can control click on a name in the script, and it'll bring you to the documentation for that name. So we have our sprite, which is our node type. So if we just control click on sprite, it'll bring up the documentation on it. I usually use the web-based documentation, but the documentation in the editor is the same thing. Is all good? Also at the end of the slideshow, we have documentation links for everything we talked about. So we talked about sprites and vector 2s, translate and everything. So yeah.
Any last questions? Yeah.
When it comes to like the performance differences in the scripting languages, the last time I looked it up, I read that there was no performance gains from using C#. In Godot 3.1, was there an update that made it so that there were?
There should have always
No,
been.
there is definitely a
Yeah.
performance difference.
C# is about 4 times faster, I think.
Which it's going to differ as GDScript gets worked on and it adds static typing and everything. But being a compiled language, it is much faster, and even faster than that is C and C++, because they're meant to be fast. They're compiled to machine code. And yeah. Any other questions?
All right. Sorry we went a little late. We were having technical difficulties.
Yeah, and the
but-
stream is probably unwatchable, but that's fine. Nobody watches it anyway.
But thank you all for coming.
Yeah, thank you all. You can talk to us. You just hit us up on Discord or in the game lab. I'm not in here very often. I should probably work on that. But yeah, see y'all later.